Hello friends, my name is Ronak and today we are going to discuss inter-process communication using pipe in C programming language. For IPC, we will require a receiver process, a sender process and a channel to pass the data. In our case, the channel is named pipe, that is FIFO pipe. Okay, so what are the steps for receiving the data? They are as follow. Uh, when we start our receiver file, it will create a FIFO pipe, then open that FIFO pipe for read data from FIFO pipe until end of file is occurred. When end of file is occurred, while reading the data, stop reading that FIFO pipe and end the process. So on receiving sender side, we will check first if the FIFO file already exists. If FIFO file does not exist, uh, this means receiver is not yet started and it has not created FIFO pipe yet. So terminate the sender process because there is no receiver. Okay. If FIFO file already exists, open FIFO pipe for writing data. Write data on FIFO pipe, whatever we have to write, and close that FIFO pipe, and then terminate the sender side. Okay, let's see the C programs, what we have to do in C programming language. Okay, this is receiver file. The purpose of receiver file is to receive and display character data from another process through name pipe. That is, whatever data we receive, that data will be of character array and we will store it and display it on screen. This is today's state, and let's continue. We have to include three files: stdion.h, fcntl.h and sys/stat.h. In main function we will write our code. uh, we have to we have four data types here: data, fd, len and I. Data is of type character array and it has capacity of 100 elements. We will store received data into this array. We have ft is an integer type, and we will store file descriptor of pipe in this. We have another variable len. We will store byte count read from read function, and we have another temporary variable I to maintain number of strings read. Okay, our first step was to create a data pipe, to create a name pipe. So just to be sure, we will remove our name pipe, data pipe, if it already exists. We will use unlink function for that. Next we will create a FIFO type file. For that we have a function mkfifo, and we will pass two arguments: data pipe, that is name of our pipe, and we will write permissions here. First 0 is for octal, first 6 is for user permission, next 6 is for group permission, and this for others permission. We will give read and write permission to user and group as well. Okay. Third step was to Second step was to open the file, open the FIFO file. For that we will use open function, and we will use open it in read only flag. We will open it with read only flag. Okay. Now error checking. If we cannot open the file, we will display error creating pipe and we will return with error. Okay. So here is our main loop for reading the data. We will read infinitely, and we will read from pipe to data, and max capacity is 100. Okay, and how many characters we have read will be written into this len. Okay, now if we read 0 or less than, that means we have stopped to end of we have reached to end of file. So we will have to break the loop and come out of the loop and finish the loop. Okay, if we have read more than one or more than one, then we will add a /0 as a terminator for string, and we will display the data with this function and increment I for string count. Okay, Now whenever we are done with the file and any file, we should close it. So close ft, and then to make sure that receiver program is closed, no one use the data pipe to send data to receiver, we will delete this name pipe too, and we will return 0 successful return. This is the sender file, sender.c. This file is to send the character data to the another process through name pipe, data pipe. Okay, this is today's date, and for same as receiver.c, we have to include 3 files. We have in main function we have 4 variables: data, ft, len, and I. Data is to store data temporarily, which is to be sent. Ft stores the file descriptor of the name pipe. Len is to store the byte count read by read function. Okay, now our first step was to check if data pipe already exists. If it exists, then proceed. If does not exist, we have to return. To check, we will try to open the data pipe with read only function. We will not try to create new one. If it does not exist, it will return an error, and fd will store -1. If ft is -1, that is data pipe does not exist, we will say that receiver process has not created FIFO file yet, and we will return. Okay, now if we get successfully file descriptor, we will try to read data from terminal and write it to the pipe. Okay, this is the loop to read data from the terminal and write it to the data pipe. To read it from the terminal, we use read function. As everything is treated as a file in the Linux, terminal has a file descriptor 0, and we will store data read from terminal into data, and max capacity is 100, so we have written 100 here. Okay, how many number of bytes are read, that much will be written into len, and if the len is less than or equals to 1, that is if user enters a blank line, we will have to stop reading. Read function will also return /n, that's why 1, otherwise it would be 0. Okay, now if we read a line successfully, we will write that data to the data pipe, and size if number of characters read. Okay, now when we are done, we should close the file, and as we are done successfully, we should return 0. Okay, now it's time to execute them. So we have 2 files, one sender and one receiver. So first compile it, and then we will execute it. So for compiling, we will write gcc sender.c -o sender.out. Okay, successfully compiled. Then we will compile gcc receiver.c -o receiver.out. Okay, this is also successfully compiled. Let's clear screen. Okay, as we saw earlier, we have to first execute receiver, and then we will have to execute sender process. Okay, so we have to execute 2 processes simultaneously. So we will have to open 2 terminals, 1 and 2. So let's first execute receiver process by issuing command /receiver.out. Okay, receiver has started. Now let's start sender process, sender.out. We will write hello friend. Okay, successfully read by the receiver. And now let's write I am doing well, networking is fun. Whatever we want to write, we can write, and say I am done writing, so I may enter a blank line, and we are on done at this. Sender is closed, so that receiver receives end of file, and when receiver receive end of file, it will also terminate. As this is my first video tutorial, I would like to dedicate this tutorial to all my teachers and professors from school to college. As this is about networking, special thanks to Professor Bhavesh A. Patel sir and Professor Prabha Kumari madam for teaching me networking. And thank you for watching this tutorial. I hope you like it and this be useful in your career. Thank you.